The students playing right now are not that great.
No, but I mean the boards. Who donated?
One of them was bought. One of them was donated. It was found on Craigslist for free. For free.
How do you find it on Craigslist?
Some guy had to move out.
And you just like take this crazy.
He's like, I'm donating it to a school.
Oh, okay.
He probably wrote it off for like twice as much as it was worth.
Awesome.
Yeah, but whatever.
So when you say I'm not that good, does that mean like you don't pride yourself?
I'm not a particularly good player.
Like, can you spin?
Yeah, I can get some spin on it.
Okay, so you're probably mediocre.
I can't get a crazy amount of spin.
Okay.
My forehand isn't consistent enough.
I just suck at ping pong.
Me and Elijah have this weird ping pong thing. Elijah, every day at lunch we're gonna play ping pong. Every single day at lunch we're gonna play ping pong.
Wait, you don't have to go to college office at lunch anymore?
I don't have to. I just kind of stay there because it's air conditioned.
Yeah. Have you heard of Just Be Friends BL version?
No, Ferreria, don't look it up.
That just sounds bad.
Ferreria, don't look it up.
Sounds bad already.
Don't play it with students around.
Stop.
Okay,
He doesn't have to experience.
it's obviously BL version, so.
Okay, we'll try one of these.
When I read those lyrics, I was like, what the?
It's catchy without the lyrics.
Shut up.
Okay, so I come from Key Building, the other side.
Go kill yourself.
Just shut up.
You know what? Oh, you should bait Valerio into playing, because Valerio's good.
At ping pong?
Yeah.
I could totally bait Valerio on the phone.
Yeah, because obviously he's
he has a
Filipino,
gambling
so.
addiction, right?
Yeah.
Oh my god. I was like, hey Valerio, play for $5. Him and I golf.
Yeah.
You win?
I think he beat me by like 5 strokes. He was really sad. I was disappointed. He woke me up at like 6 in the morning. It was awful.
He called you and he's like, let's go play golf. I'll bet you $5.
He was like, I wake up earlier than this every single morning. I'm like, I don't.
Mr. Valerio. Okay, we're gonna get started. We're gonna get started.
No, Valerio's a conservative player.
He's not like you where you keep buying back in every time.
I bet a lot.
Yeah, and you buy back in every time.
Number 1. Okay, so we're measuring age, marital status, earned income of an SRS of 1463 women. So it looks like we're only measuring 3 things. So we're measuring age, which is quantitative. Okay, and you can tell it's quantitative because if someone asks, what's your age, you're going to give them a number.
Yes.
Okay. The next one is marital status. Okay. And if someone asks you what's your marital status, you wouldn't say 23. You would say either married, single, whatever.
Could you turn that into quantitative if you turned it into like a binary thing? That it's either 1 or 0?
Yeah, we'll get it. Yeah. So marital status is categorical. Number 3 is you're also asking earned income.
What's that?
Wait, what if they gave like a specific range for those quantitative ones, like ages between 20 to 25?
Yeah, so that's a way of turning a quantitative variable into a categorical variable. We had over here, there's actually a way to make a categorical variable into quantitative simply by assigning quantities to, let's say, marital status, enter 0 for single, enter 1 for married.
That's when you turn it from categorical.
Exactly. All right, so earned income, that's a number. If someone asks you what's your earned income, you would say $27,382. That's a dollar amount. That's a number. So quantitative. I hope you make more than that. All right, so that's 3 variables. Two quantitative and 1 categorical. Am I spelling that right? Am I crazy? Quantitative.
Quantitative.
Is that right? Two. Consumers Union measures gas.
You see how it says 3?
That's for how many different variables?
Yeah, how many variables? The number.
Does that mean age, marital status?
So where they're asking you for the number of variables and the type of those variables. Number and type of those variables. So we're saying there are 3 variables, 2 quantitative, 1 categorical. Number 2, Consumer Union measures the gas mileage in miles per gallon of 38 cars on a special track. The pie chart provides information about the country and manufacturer of those model cars used by the Consumers Union. Based on the pie chart, we can conclude that Japanese cars get significantly lower gas mileage than other countries. This is because their pie slice is at the bottom of the chart. That makes no sense at all.
Hey, you wrote the answer to this.
B. U.S. cars get significantly higher gas mileage than the cars from the other countries. Again, does not make sense. This pie graph does not tell you anything about the mileage. It tells you proportionally how many cars came from each country, but it doesn't tell you the mileage of those cars. C. Swedish cars get more gas mileage. We have no idea because we're not measuring gas mileage in this pie chart. D. Mercedes. Okay, now that's just crazy talk.
That implies that we know what all of these places come from.
Where are Audis from? Germany.
Audi isn't German.
How about Mercedes?
That's not
These are
true.
all German. These are all German.
Audi's
No,
German.
no. A Porsche is Porsche German?
Porsche isn't German.
A Porsche is German?
No. Look it up.
I don't know about Mercedes.
Mercedes German. Yeah, they used them in World War II.
I need to know, where is a Porsche from?
Porsche's from Germany because the Germans made it during
Yeah,
World War II.
Can you
German.
confirm Audi though?
Audi?
Audi is not D.
What?
Audi
German. They're all German.
Guys, they're all German.
You guys know the BMW logos from World War II? How does the helicopter thing?
It's a propeller, yeah.
Yeah.
And when the wheel spins, it looks like.
Okay, so that implies that the German cars are
A quarter of the
a quarter of the cars tested. That Germany slice does not look like 25%. And in fact,
Even if it was, I don't think, because you didn't writing this question, you didn't know it was German.
so that tells us that the answer should, oh my gosh. That tells us that the answer should be E, but let's just check to make sure. More than half of the cars in the study were from the United States.
This question, the test.
Definitely. Okay, so E is the correct answer. A through D asked about car mileage, which is no, A through D, A through C, which is not represented in the pie chart. D implies that German cars are at least 25%. Okay, the pie chart contradicts that, right? So E, which is correct, the US slice is clearly more than 50%. AP Common Sense, right? All right, any questions with 2? 3. A researcher reports that on average the participants in this study lose 10.4 pounds after 2 months on a new diet. Okay. A friend of yours comments that she tried the diet for 2 months and lost no weight. So the report was clearly fraud. Which of these is correct? Note how it says that on average participants lose 10.4 pounds. That says that some people lost less than 10.4 pounds. Some people lost more than 10.4 pounds. Some might have gained weight. Okay. So we're talking about an average, which is not any one person's results. So your friend must not have followed the diet correctly since she did not lose weight. No, that's not what they're saying. Okay. The average weight loss is 10.4 pounds. Some people will lose more, some will lose less, and some may gain weight. 10.4 only represents the average weight loss. So, B, since your friend did not lose weight, the report must not be correct. No, I would not feel comfortable saying that, even though if you're the person who gained weight on this diet, then you probably would want to sue. C, the report only gives the average. It does not imply that all the participants in this study lost 10.4 pounds, or even that all of them lost weight. Your friend's experience does not necessarily contradict the study results. Well, that's the longest answer, so it must be true.
What?
D, in order for the study to be correct, we must know how your friend's result. We must now add your friend's result to those in the study and recompute a new average. No. The study stands independently of what happens after the study.
Your friend is an outlier.
E, your friend is an outlier. Now that's very tempting depending on how much you like your friend.
No, because it's computing average, which is associated with mean instead of deviation. If it was calculated by median, then you would have.
But do you know that?
What?
You can't assume that without doing that.
That's true.
Why is it D? Because it can be argued.
If they said the range was that it was like the reporter gave the range and then it would be different.
Okay, the problem with D is your friend was not part of the study. There's no reason to add her to the study. Any others?
How would E for E, can it be true?
Well, no, your friend is not part of the study.
At all?
No. How can your friend be a part of an outlier of the study if your friend is not part of the study? Warner, did you have a Oh, okay. 4. The following is an ogive. Yay, ogive.
Wait, what's an ogive?
Okay, so it's an ogive for the number of ounces of alcohol consumed per week in a sample of 150 students. I hope these are college students. The study wishes to classify the students as light, moderate, and problem drinkers
Heavy and problem.
by the amount consumed. What percentage of students are moderate drinkers that consume between 4 and 8 ounces a week? So 4 ounces is approximately 20 percentile. Okay, so 4 ounces is approximately 20 ounces. No, how many ounces? Approximately 20 percentile. And then 8 ounces. Did you say 40?
No,
60 percentile. So approximately 40% of all the students in the study are, is that moderate?
Yes.
Moderate.
Where did we get 40?
40, 60 minus 20.
It's as simple as that?
Yeah.
Yeah.
Really?
Between 4 and 8.
Yes.
It's 60 minus.
I'd rather go back to Cal.
But it is 60 plus 20 divided by 2.
Oh, is it just finding the average between the two?
But you wouldn't even know the number.
It just happens.
No, they want to know what percentage of students are in between 4 ounces and 8 ounces.
So you subtract
Okay,
the two?
so you subtract the two, yeah. 60% drink less than or equal to 8 ounces. 20% drink less than or equal to 4 ounces. So what percent drank between 4 and 8 ounces? 60% minus 20%.
So you never need to find the average.
No, this is not about an average.
That's how you find the
Numero 5. Okay, so normal body temperature varies by time of day. A series of readings were taken of body temperatures. The mean reading was 36.5 with a standard deviation of 0.3. Okay, when you convert this to mean, what would be the standard mean and standard deviation? So let me just kind of clarify what this means. If the data undergoes a linear transformation, which just means multiply and add, okay, then the mean undergoes the same transformation. So what we're seeing in this one is we have, what was the mean?
36.5.
Okay, so Fahrenheit is equal to 9 fifths? 9 fifths?
Yeah. No.
1.8. 1.8 times C plus 32, right? So the new mean is equal to 1.8 times the old mean. What was our old mean? 36.5 plus 32. So our new mean is 97.7. Okay, and if the data undergoes a linear transformation, then the standard deviation does not undergo the same transformation. It's only multiplied.
What do you mean it's only multiplied?
Exactly.
Okay. Is that just a technicality, or is that? I'm confused. Why is that?
I'll talk about that in 1 second.
Okay.
So here we go. Here's the transformation, right? So the standard deviation is equal to 1.8 times the old standard deviation. The old standard deviation was 0.3. So my new standard deviation is 0.54. Okay. And here's kind of the way this works. If you multiply everything in the data set, all the observations, that kind of changes the way that the numbers are spread out. The numbers that are far away get even further away. The numbers that are close stay close and are multiplied just a little bit. So the spread actually changes with multiplication. But if you add something, that only takes the spread and just kind of moves it over. It doesn't change the spread of the data. Adding does not change the spread of data.
Multiplication does.
Multiplication does change the spread of data. Adding and subtracting does not change the spread of the data.
It only shifts it from.
Yeah.
So why is it necessary that we bring that? Why is it necessary that standard deviation isn't added along?
Because standard deviation is a measure of spread.
Oh, okay.
Any questions on 5? 6. The following is a histogram of the actual frequency of the closing prices of a particular stock based on the frequency histogram of the New York Stock Exchange, the class that contains the 80th percentile. So we got to figure out which one of these is the 80th percentile. Hey. Hello. So there are 50 stocks represented here. $50 stocks in the sample. Okay. The 80th percentile would be the 0.8 times 50. It'd be the 40th stock. So all you need to do is count until you get to the 40th stock. Okay, so stocks numbers 1 through 13 are in the first bar. Stocks 14 through 21 are in the second bar. Stocks 26 through 22 through 36 are in the third bar. Stocks 37 through 43 are in the fourth bar. Maybe I should write that down. Okay, so the first bar is stocks 1 through 13, right? The second bar, that's stocks 14 through how much? 21. The third bar is stocks 22 through 36. The fourth bar is stocks 37 through 43. The fifth bar are stocks 44 through, did I hear 46? 46? The sixth bar is stocks 47 through 48. Why am I missing a stock?
Did you subtract one by accident?
I don't know. Did I?
There's like 50. 50 exactly.
Seventh bar is 49 and 50? No.
Seventh bar is 1. Seventh bar is 1.
Seventh bar is 1. Okay, so
And
it's
then the eighth bar is. Then there is no eighth bar. Then the ninth.
stocks 40. Stock 49, right?
Yeah.
Eighth bar.
That's not necessarily on the test, right?
Ninth bar is
We're not gonna
stock
do this, are we?
50. No, this is just to kind of
Like I just wrote in between the boxes.
bold. I'm just doing this for the people who are not here. Median is here. No, not the 80th. 80th percentile, right? Yeah.
The 6 bar is 3 stocks in it.
No, 47, 48, and 49. Wait.
47. 6 bar has 3 stocks.
So that's
It's supposed to go to 45, not 46.
Yeah.
45.
From 46 to 48.
Okay, good.
Yeah.
All right, so that's it. So that's where the 80th percentile is. Remember, the 80th percentile was a stock number 40. That's 6.
D. E. Right? E's in Eddie. Because it's in the
E,
fourth
yeah.
one.
Yeah. You remember we said it's in the fourth bar. The fourth bar is 30 to 40, which is E.
6 period. Yeah. What? What are they missing?
7. If the mean is smaller than the median, that means this is a left skewed distribution. So the question becomes, which of these is a left skewed distribution? Okay, so a lot of things in the upper end, not a lot of things in the lower end. The salaries of national football players. We have a lot of people making a lot of money, not a lot, just a few people making a little bit of money. I think that's backwards.
That's right.
Okay. The scores on a test of a very easy test. So we have
A bunch of high scores and very few.
a bunch of high scores and then
Couple low.
yeah,
Is that it?
that's left skewed, right?
Yeah. I think so.
So
There's going to be a lot of high grades and it's slowly going down, which would be a right skew.
you have, put the numbers in numerical order.
Oh, in the numerical order?
Yeah, so it would be B.
Oh, so D is the antithesis of that. Because the high numbers are in front, and then the low numbers are.
That makes sense. If it's in numerical order, then would it they if a lot of people are making money.
Are you okay with B?
Wait, but I'm still kind of confused though. If it's in numerical order, if a lot of people are making a lot of money, then is there still be left to do?
Yeah, but in the NFL, most people are making minimum.
Oh, okay, so.
And then there's some people who are making like 30.
Yeah.
So for 10, it's like there's a bunch of 4s, and then there's a couple 4s, and then 20 hundreds. Right? So all of the data is on the right side because the majority of the people did well.
It's like an AP
So
exam,
for
like
part D,
80% is supposed to be
it's
those
the
five.
majority of people have like 20s out of 100. Then like a few people have 100s.
Yeah.
So all the data is on the left side, therefore it's right.
Yeah. Okay, the prices of homes in a large city.
No.
Would that be right skewed, left skewed, or symmetric? Okay. Do we have a lot of low price homes and just a couple of high price homes?
Actually, no, but there's
It
fewer.
depends on
It's
where
right
you are in
skewed.
the city, though.
It's right skewed because there's not. No, because you're gonna have houses. A majority of houses are gonna be like $250,000, and then every once in a while you're gonna find one that's 10 million.
Yeah, but it's too
And
big
that's
of
an
New York.
outlier.
It's
New York
nice.
City
Yeah,
is
it's very
all
big.
the-
What if you go to Beverly Hills? There's nothing to
I know, but there's no matter what, there's gonna be that outlier that's 20 million.
No, it's not. It can't be seen because it's such a big city.
There's too many variants in that way.
Yeah, it's too big.
Okay, D. The scores on a very difficult exam where a lot of people get low scores and a few people get high scores. That's right skewed. Okay, we have a lot. We're heavy on the left side, so it's right skewed.
Like our first exam.
The amount awarded by civil court juries.
How would we know?
So do they tend to award a lot of money, or do they tend to award more?
No, that's not true. No, you can assume that very few cases result in people winning millions of dollars. Well,
That's something a normal person would know, though.
no, but no, it's common knowledge. It's not ever. Very few people win in court.
Or at least a lot.
Very few people win a lot of money in court.
Yeah. Usually it's the minimum because our government likes to choose that.
Again, vague.
So it seems as though the best response here is B.
I really understand. Not a lot of people get a lot of money.
Most people.
No, because a majority of the people who don't make money are on the left side. E is right skewed because all of the people who did make a lot of money here, and then there's very few people over here who make a lot of money. So it starts out all of the data is on the left side, therefore it's right skewed. Does that make sense?
How do we do? Are we good?
Yeah. Can you define variance?
Wait, isn't it in all the data's on the left side? It would be left side.
No, it's the opposite. All the data is on the left side, it's right skewed.
Turn off your brain. Really? Yeah.
Wait,
I wish I could turn off my brain.
Let's use like 6 as an example since there is a graph. That'd be right.
Yes.
Oh yeah,
that would be
okay.
right.
Yeah. All the data's on the left.
Okay,
Okay.
8. We have 3 children in a room. They're aged 3, 4, and 5. A 4-year-old child enters the room. Will the mean stay the same or will it change?
The mean stays the same. You can
Cur-
just calculate it.
Currently the mean is 4. If another person enters whose age is exactly the mean, it's going to be the same. Okay. So the mean's going to stay the same, which means D and E are wrong. Okay. Variance is a measure of spread. Okay. With 3 the mean is 4. Okay. When that fourth child gets in there, we've only added 1 person to the mean. We've added 1 person to the center. Okay. So that actually makes the spread smaller. Okay. If the 4th child with age 4 is a room, the spread decreases. Okay. Because, yeah, most of the children's ages are close together. We have 2 of them that are age 4 now, and so the average difference becomes smaller. Maybe you should put that. The average difference from the mean gets smaller.
So any kind of additional data will change the variance, even if it's like the same as something else.
But why does it decrease?
Yeah.
Yeah, can you explain?
I guess
Can you
that's
show
the
that
case.
visually?
Yeah, you know what? Why don't we do this? Let's just compute the variance. Okay, here's the variance. Oh, you're gonna love doing this. You're just gonna. It's amazing. Okay, so the variance is equal to 1 over. This is the old one, right? The old variance is there are 3 children, so it's 1/2. The first person is 2, right?
3.
Oh, 3. 3 minus, what's the average?
4.
Squared plus 4 minus 4 squared plus 5 minus 4 squared. Okay, so that's 2, so that means the variance is 1, right?
Yes.
What about the new variance?
Why is it 1
Because there is 1 over n minus 1. So now we have 4 children. 4 minus 1 is 3. So we still have 3 minus 4 squared. We still have 4 minus 4 squared. We get an additional 4 minus 4 squared. And then we have the 5 minus 4 squared. The mean is still 4, right?
Oh, it makes sense. If you add over ages and divide it by 4, it's going to be equivalent to 12 over 3, which is the original. Oh, it makes perfect sense now.
It's the definition of variance.
Can you say the equation the
Yeah, it's is equal to 1 over, wait, let me finish. 1 over n minus 1 times x1 minus x bar squared plus x2 minus x bar squared plus dot 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 plus xn minus x bar squared.
And if we plug just these numbers into our calculator, it's the line with the.
Yeah.
So this that's really easy. And you just plug in an extra number and okay, cool.
So it looks like the variance is going to decrease. Think about it. You're adding more to the middle. How is that going to make the variance do anything but decrease?
Oh, that makes sense.
So if the number 2 was added or the number 6 was added, the variance would stay the same.
You know,
2 or 6?
it increased because you're adding more variety.
We're adding more to the end now.
Oh, okay.
So the variance is going to increase. Add it to the middle, the variance decreases. Add it to the outsides, the variance increases.
Anywhere else, like even if it was 3, then like anywhere else it would be added. Like if say we added another 1 that was 3, then it would still increase. So
Probably, yeah.
it'll decrease.
But that, see, if you added a 3, you would also change the mean. So it's a little bit more of a calculation. Yeah.
Variance is the square root
Standard deviation is the square root of variance. Have a good night. Well, now that's not. Just kidding. Standard deviation is the square root of variance.
Is the variance only value because the same number is added? Or if you just add a number in general, what the variance is?
One more time.
Okay, so because the numbers you have is 3, 4, and 5, does the variance only go down because you added a 4? So
Yeah.
if you added a 6,
Variance would go up.
If you added any other number besides 4, it would go
if you added any other number besides the number already stated.
Oh, okay.
Well, I don't know. If you added another 4, if you added a 5, I think the variance would go up.
And isn't it anything besides the mean?
Yeah.
Besides the mean?
So even if you added a 1?
If you added a 1, the variance would definitely go up.
see it more too. Anything besides me.
Anything besides me.
Yeah.
Is this, so that's the symbol for variance?
Yeah. Maybe look at it in terms of, yeah, that's the symbol of variance. Without the square, that's square root. That's standard deviation. Look at it like this. Let's pretend. Think of it in terms of mass. Okay. If you add something to the, if you add weights to the middle, right, it would stay balanced, wouldn't it?
Yeah.
Because it's more centered. But if you added weight to the outside of it, even if you found the new balancing point, I mean, it would be out of balance. It would be, you'd have more on the outside. I don't know if that makes sense or not.
Yeah.
Yeah, because you're adding to the middle, so everything becomes more compact. Okay. I hope that worked. Questions? No? We good? Okay. Two more questions. The weights of males and female students in a class are summarized by the following box plots. Well, thank you so much. Which of the following is not correct? So the comment I want to make before we start this one is each part of the box plot is 25% of the data. Okay. So each whisker, 25%. Each small box, 25%. So when I take a look at part A, 50% of the male students have a weight between 150 and 185. Okay. So in other words, are two parts of the box plot in between 150 and 185? Yeah, 150 seems to be Q1. 185 seems to be Q2 or Q3.
Yes.
So that's about 50%. Each small box is about 25% of the data. So for part A, the IQR is located between 150 and 185. This is 50% of the data. Okay. Part B. 25% of the female students have a weight more than 130. So if I look at the females and I only see one part of the box plot greater than 130, then it's true. Yeah, 130 is Q3. Q3 for females. The upper whisker is 25% of the data. Letter C. Letter C. The median weight of male students is about 162. That looks to be true. D. The mean weight for females is about 120 because of symmetry. Does it look symmetric? Yeah. Females look symmetric. The median is approximately 120. So this is good. You're right. Because it's symmetric.
Symmetric means about the mean.
And E. The males have less variability than the females. No, but this is false. Okay. The IQR box for males is bigger than that for females. females. So that one's a false one. And finally, number 10, half an hour past due.
When do we ever
Huh?
Hey, sometimes you felt early last year.
stopped early?
Finishing. Testing the this one, Jesus. When testing water for chemical impurities, results are often reported as BDL, which is below detectable level, limit. Okay? In other words, it's a very small number. The following measurements of lead in a series of water samples taken from an inner city household. Which one is true? We can't actually figure out the mean because we don't know what number BDL represents. We know BDL is a small number. The smallest number we see is 5, so BDL should be less than 5. BDL is a number less than 5 for sure.
You actually have announcements at this time?
The buses.
Late bus riders, your chariot will be leaving in approximately 5 minutes, so head on down to the front of the school.
A, there is no way to accurately compute the mean.
Same with B.
B,
Same as A.
Sims. Same. C. The median level is 7. And does that make sense? Let's see. Take out
When I put it in there, I got the median.
take out a low and a high, take out a low and a high. C. The BDL matches with a 20, BDL matches with 12. 5 goes with 10. 6 goes with 8, so the median is actually 7, looks like, right? Hmm?
I don't think we need to check the rest.
D,
We just said it was 7, so I can't be anything.
You just said it. And then it, E, we just calculated the median, so E is wrong.
we don't know what number BDL stands for.
So how
We know it's less than
we don't know exactly what it is.
Yeah, it could be 0.1. It could be 0.1.
So you don't use decimals for.
Yeah, it could be 3. We don't know. For median, we just have to match and cancel. Median, we just need to find the number in the middle. Like, let's put those numbers in order. Okay, we have BDL,
5, 6, 7, 8.
5, 6, 7, 8, 10, 12, and 20.
See if they're in.
You can tell which one's in the middle.
I shoot just in time.
4 on the left, 4 on the right. The median is 7.
Wait, you want to?
I'm tying my shoe, you dipshits.
Bye, Mr. Ferreira.
Bye bye. You're welcome. 7 is the median.
She's like, you were